So here's another example in mathematical induction, where the question is that, let's say I have to prove that sum of 2c2, 3c2, 4c2, and so on is equals to nc3 for n more than or equals to 3. So now when I verify this identity to be true for some of the terms, now if I take n as 3, I get basically 2c2, which is 1, and I get 3c3, which is also 1. Now next up is when I take because since this is true for n equals to k, n equals to 3, it must be true for n equals to k. So I can take let's say 2c2 plus 3c2 plus 4c2 dot 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 k minus 1c2 equals to kc3. Now up till here we got the uh, assumption that is n equals to k. Now I'm going to make what I have to prove is n equals to k plus 1. So according to that, I should get 2c2 plus 3c2 plus 4c2 and dot 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 n minus 1c2. That's here this term, plus next term will be nc2, and that must be kc2 here, so that must be equals to k plus 1 c3. So I just found out the k plus 1 term, which is kc2. Now what I'm going to do next is I'm just going to take this sum which I got here is already n choose 3, which means k choose 3 here. So kc3 plus kc2, what should give me the answer is, this is what I should get. This is to prove. So I'm just going to take the LHS here, so left hand side. So kc3 I can write it as k factorial over k minus 3 factorial times 3 factorial. And this is k factorial over k minus 2 factorial times 2 factorial. So what I'm going to do is I'm going to take k factorial common, and in this part, I'm just going to take first one more step here. So k factorial is here what I get is k factorial or k minus 3 factorial times 3 factorial plus k factorial over, what I can do is this I can write on as k minus 2 times k minus 3 factorial, and also this 3 factorial I can write down this as 3 times 2 factorial, and here it is 2 factorial as well. So I now look at what all I can pull out. So I can pull out actually so k factorial over k2 factorial and k minus 3 factorial can be pulled out easily, and what is left out here is nothing. Okay, so here is left out is 1/3 actually, so 1/3 plus here it is gone, and here what we are left out with is 1 over k minus 2. And if you take LCM of this, what I get is k factorial times, take LCM of this, it'll be k plus 1 over, this is as it is, so k minus 3 factorial times 2 factorial. And if you take, this is 3 times k minus 2. And if I simplify this here, so it is k factorial times k plus 1 is nothing but k plus 1 factorial over k minus 3 factorial times k minus 2 is actually k minus 2 factorial. Bigger number is this. And 3 times 2 factorial is 3 factorial. And if you look at this, it is nothing but k plus 1 c3. And that's what I wanted to prove. So since it is true for n equals to 3, n equals to k, n equals to k plus 1, hence it is true for n belonging to z for n more than or equals to 3. So that's what we wanted to prove. I hope this is helpful.